Hello, today we're going to look at a gravitational field question. So this is also similar to gravitational forces, and it's going to have a gravitational force. We're just going to look at it briefly in part C as well. Okay, so gravitational field at point A. So this is our diagram that we have here, and we have a mass 1 on the left, 45 kilograms, mass 2 on the right, and then we pick a point that's not quite in the middle. It says it's just slightly to the left of the middle, and you go straight up from there 5 centimeters, and that should be point A. Okay, so we made this point A, and it's asking the field strength. Well, I'm going to try to solve everything related to this in green here so we can distinguish them. So field strength is G equals big G M over R squared. So in this case, the M going from A, it's going to feel two different fields, right? It's going to feel field this way, pulling it towards M1, and it's going to feel field going this way, pulling it towards M2. Okay, so I'm just going to draw those two arrows down here. It's going to feel a field strength that way. So I'm going to call this G1, and I'm going to call this G2. The masses are easy. So mass of G1 is just the mass 1. Okay, but what is the radius? Well, we have to use Pythagoras to find the radius. So let's look at this first one. And we can look at this side here. We know there's going to be two triangles here. This is 5 centimeters. These are both right angles. It's 5 centimeters. This is 7. Okay, and I'm going to plug this into my calculator using Pythagoras. So that means c squared equals a squared plus b squared. C equals a squared plus b squared. So you can make this c, or you can make this c, and then this will be a, and this will be b, or this will be a, and this will be b. Okay, so I'm just going to plug that in to get the c on both sides. Okay, c on both sides. So square root of 5 squared plus 7 squared. So this is of the right side here. Changing it to answer 8.6. Okay, this is just a magnitude this is centimeters of the radius. Okay, and 5 squared plus another 5 squared is 7.07 centimeters on that side. Okay, and remember, you don't want to round prematurely. So keep long numbers here. Don't just use sig figs. Okay, use long numbers at first, and then your last answer should be sig figs. Okay, so those are your radii. So if we're calculating, like back here, if we're calculating our G1, G1 equals G M1 over R1 squared. So R1 is just this R1 here. Okay? And this here be G2 equals big G M2 over R2 squared. Okay, plugging those values in, I have 6.67 times 10 to the negative 11 times the mass of M1. Mass was 45 divided by the radius, 0.07 centimeters squared. So if it's centimeters, we need to convert to meters. That's always something to check. So I just did the calculation. G1 equals 6.00 times 10 to the negative 7. And G2 is going to equal 5.4 for 1 times 10 to the negative 7. And what are these? Well, they're both meters per second squared because they are field strength. Or you can work through unit analysis. Both are good. Oh my goodness, this keeps popping up. Okay, so they're both good. That's our magnitude of our two, but they're vectors. So how do we add vectors? If you don't remember, please look at that video. But you can add vectors tip to tail. So I found the tip of this one. How would I do that? The tip of this one here with the tail of this one. And I put them next to each other. So the tail of this one, the tip of this one, I put them next to each other. Okay? So this one here is G1, this is G2. But I don't really know I don't know the directions of these right now. So I need to find the direction. Well, the direction should be the same as the direction of the radii. So this part here, right here, the triangle should be the same shape. So if we use tangent or something, we can find the theta at any point. So let's find the theta here, call it theta 1. We'll find the theta here and call it theta 2. Okay, so to find it on the left side, let's use tangent. So it'll be tan to the negative 1 of opposite over adjacent, which is 5 over 5, equals 45. Lovely. What a lovely number there. So this number here is going to be 45. We want to find theta 2, which is going to be opposite over adjacent. Opposite over adjacent. So it's going to be tan to the negative 1 of 7 divided by 5, which should be 54. Okay. So this is telling you that this is not going to line up here. They're not going to be at a perfectly perpendicular point here. G1 is going a little bit further. Or G2 is. Can't remember. But regardless, now you should break it up into the two vectors just so you can get a better sense of what's going on here. So let's break up G1 first. And I'm going to get rid of all this stuff for G2. I'm going to put G2 over here. G2. And the direction I said was 54 here. Okay. Right angle, right angle. Okay, so now you can find G1 perpendicular, G1 parallel, G2 parallel, G2 perpendicular. And at this point, you can use, so I'm just going to show you one, G1 perpendicular equals, it's the adjacent side to the angle, so it would be G1 cos 45. G1 parallel equals G1 sine, because it's opposite, 45. And then G2 perpendicular equals, and if we want to look at these directions here, this direction is that way, this direction is this way, this direction is this way, this direction is this way. Oh. So Something funky went on there. Okay. So G2 perpendicular would be, it's the close side again, it's the adjacent side, so G2 cos 54 and G2 sine 54. Okay, and if you look at these arrows again, this one's down, and so is this one. And the other arrows, this one's this direction, this one's this direction, so they're opposite. So we have to subtract the one set, and we have to add the other set. So to get our full vector diagram, we have one side like this, and we have one side added with this slightly bigger. Alright, so these are our two sides that we're looking at. And I'm going to tell you that this side here on the left is just a product of the two perpendicular sides. So this is our net. I'm going to call it G net perpendicular and G net parallel. And G net parallel is equal to G2 parallel minus G1 parallel. If you do the calculations with those numbers, you're going to have bottom here 1.37 times 10 to the negative 8. Okay, and if you do this calculation up here, this should be G1 perpendicular plus G2 perpendicular, which should equal 7.423 times 10 to the negative 7. Okay, and when I look at this extra force, so this is not very clear. So this red dotted line is the resultant force. This is our not resultant force, sorry, resultant. So this dotted red line here is the resultant field magnitude and pull that we need to calculate for. So using, again, the C equals square root A squared plus B squared formula, we are able to find that this is 7.424 times 10 to the negative 7 meters per second squared. But now we need the direction. So we need to find theta. Theta is just going to be tan to the negative 1 of opposite over adjacent, sorry. So 1.37 times 10 to the negative 8 over 7.423 times 10 to the negative 7. Do that calculation, you should get 1.06. And if you look at this, this is south, right? Straight down. I'm going to call it east of south. So our final answer is 1.06 degrees east of south. If we look at all the sig figs all the way through, we should have a final answer of 7.4 times 10 to the negative 7 meters per second squared, 1.1 degrees east of south. So this should be our final answer for part A. Now you're worrying right now because there was a part B, and part C and a part D. But these ones are way faster than the others. So if we look down here at part A, at point B, so point A we just calculated, but point B, well, it's going to be the exact same distances as A. The directions are going to change though. So at A, we had a direction like this, we had a direction like this. Now at B, we're going to have a direction like this, and have a direction like this. And this here, this G2, and this G1, the bottom here, I'm going to call this one G2, and this G1. In terms of magnitude, they're going to be the same, because they're being affected by the same mass. And the radius is going to be the same, because there's still the same triangle in here. Dot, 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 down, dot, 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 left, right? So this is the same triangle as this, right? So since they're the same triangle, the radius is the same. So B is going to feel the same strength. Okay, but how do we think about the direction of it? So we're going to call it the same strength, 7.4 times 10 to the negative 7 meters per second squared. But what is the direction? Well, if this one was going down because the G2 parallel was bigger, the G2 parallel is going to be in the same direction, but these ones are going up. So our new diagram here will look like this, and then a small one to the right. So if we draw this resultant force, this in here would be our theta. So our theta will be the same because all the magnitudes are the same. So our theta is 1.1 degrees, but now it's north and it's east of north. So east of north. There you go. That was part B. That was easy. Okay, now part C. If at point A you add a mass of 100 kilograms, okay? Well, acceleration of the mass, let's think about it. What is the acceleration of the mass? Did we do a calculation for acceleration? Why, yes we did. Right there, that's an acceleration. Acceleration with the direction and a magnitude. Wow, that's great. Let's just plug that in. That's our acceleration. So 7.4 times 10 to the negative 7 meters per second squared. And acceleration always needs to have direction, so 1.1 east of south. I just couldn't remember. Of south. Great. So there's our acceleration. What is the F net? Well, F net is always ma, right? Well, we have the acceleration, so we just need to multiply by the mass. Mass is 100. Multiply it by 100, so 7.4 times 10 to the negative 5. 100 subtracts 2 on that exponent there. Meters per second squared, and same direction. East of south. Okay. The other way of looking at this exact same thing will come when we compare and explain. So I'm just going to compare and explain everything here. So I did a comparison for B already. And I compared for here, sort of. But the other explanation of all this part is all we've done is calculate for G before, m over r squared. And this is m of the either it's m1 or m2, so I'm going to call it m of the object. Okay, I'm just making it up at this point. M of the object, and this m here is the m of the mass we added. So I'm going to call it mass added, ma. So we've got g mo over r squared times mass that we added. And I'm going to think about this. This looks an awful lot like Fg equals g m1 m2 over r squared. Though some of these things are looking pretty similar, right? So in reality, if you get one of the two values, you can find the other one just knowing the relationship between these.